Hi. Today's lecture is about the convolutional layer in a CNN. I have included these first three slides in order to give you a context of the lecture. I would not deliberate upon them more, just scan them. And here is some notation that you might find useful in order to specify the design of convolutional layer in a CNN. And now let us go and explain the working of the convolutional operation in a CNN with the help of a concrete example. So we have this image with the indicated size. We use this notation in order to denote the convolution operation, and this is the kernel which contains the weights and the bytes to be trained, and the size is indicated by this notation, and we have an output feature map when the kernel would be used on the input feature map. The output feature map would have a size of 4 by 4 for this specific input feature map, and the size calculation of the output feature map is according to this logic, this formula. Um, so the explanation of the convolutional operation is like this. So each output value of the output feature map is calculated by the usual neuron operation. And the input vector for the neuron comes from the input feature map as the kernel is moved across the input feature map. And the weight vector comes from the kernel itself, weights as well as the pies. And we can use this mathematical notation in order to represent the operation of the neuron. So the kernel is starting at the top left corner of the input feature map. The kernel is moved across the input feature map in strides or steps, left to right and top to bottom, performing calculation at each step, at each stride. The stride is usually a user selected choice. It is a hyperparameter, right? So so yeah, so let us assume that this is the first stride. So the operation would be performed like this. So this is the input feature map unfolded, and this is the kernel unfolded, right? And the kernel is moved across like this, right? So here, here, and here. And subsequently, the next value of the output feature map is calculated according to this neuron computation. Y hat here denotes the next value of the output feature map. So this was the first stride, right? Now, the second stride. So the kernel is moved to the right by one position. So because the stride amount is one. And again, the calculations are performed by the usual neuron operation, which gives us the next value of the output feature map. And this goes on until the entire input feature map has been scanned and the output feature map has been generated. So here is a view of the two strides placed side by side in order to give you people a clearer, more clear understanding of how it works. One important point is that the number of output feature map would be equal to the number of kernels used. So here there are two kernels, for example. So there would be two output feature maps. An important consideration in the design of a convolutional layer in a CNN is the choice of the right convolutional hyperparameters, which include the number of filters to use in a convolution layer and the size of the filter and which activation function. The usual choice is the ReLO or any of its variant, one of its variant, but it can be any other activation function. The stride is one or more. Typical choices here. Typical choices are usually 32, 64, 128 for the number of kernels or filters. And the size of the filter is typically 3 by 3, 5 by 5, 11 by 11, 1 by 1. The kernel is geometric shaped usually, square shaped, though other geometries for the kernel have also been proposed, but the preferred one is the squared kernel. So I hope this gave you an initial preliminary understanding of the convolution operation in a CNN. We would meet in the next lecture.